Hi everyone, I'm Sachin Ganesan, an application developer at ThoughtWorks. I welcome you all to the 47th edition of Geeknight Coimbatore. And today we'll be having two topics. And the first topic is touchless experiences with IoT and XR. Vishnu Satyanarayanan, an application developer from ThoughtWorks, will be presenting it. Followed by that, hardware security in Linux using TPM. Murugesan and Nandita, application developers at ThoughtWorks, will be presenting that. Thank you. Hope you will have a great evening. And then an application.
Sasi, I should start.
Yes, Prabhu, you can start now.
So, good afternoon, everyone. Start from it currently. So, good afternoon, everyone. So, I am Sri Vishnu, developer at ThoughtWorks. So, welcome to the 47th edition of the Geek Night. So, in this session, we are going to see about the touchless experience using IoT plus XR. So, before we going into the session, we will be seeing what is IoT and what is XR. So, as many of you heard the terms IoT and XR, so I'll just explain this. So IoT stands for Internet of Things. So here things are like devices, sensor, machines, etc., which can communicate through the internet without the help of the human and human to machine interaction, which can communicate through a wireless networks. So yeah, so we'll be seeing what is XR. So XR stands for extended reality, which encapsulates augmented reality, virtual reality, and mixed reality. So it's just an umbrella. Extended reality is just an umbrella in which it contains all the realities. So it's just like a common name for this three. So yeah. So yeah, we'll be seeing what are this VR, AR, and MR. So first, virtual reality. What the virtual reality do is it actually cuts the real physical world to the user, and it only shows the computer generated reality, which is a total of virtual reality. So the next AR, augmented reality. The word augment means add something. So as the word suggests, so it will add the digital elements to the real world to the user to see it. So next one is the mixed reality, which combines both the elements of the AR and VR in the real world and the digital objects to interact with the user. So I'll just pause to the users to see the current slide to read it. So in the next slide, we will be seeing about the Ajanta. So what are we going to do in this session, and what are we are going to learn? So I have split this session into 4 subtopics. So yeah, in the first subtopic overview, in that we are going to see what we are going to do. So how this will be going to experience in the COVID-19 situation, and in the second subtopic we are going to see IoT. In IoT, we are going to see MQTT and how the MQTT works, and connecting with the ESP8266. In the next subsession, we are going to see the XR and creating an image target in Euphoria and creating a virtual button. At last, we are going to implement the IoT plus XR. So what you are going to do. So basically, we will be controlling this LED using IoT and XR without the touchless experience, using the touchless experience. Okay. By how we are going to press this virtual button, which is placed on top of the physical button. Okay. So let's go to next slide. So how it will be helpful at this COVID situation? So before going to that, I will be explaining the germophobia, which is basically a fear of germs or bacteria. So a person has the fear so that he will be getting you affected by these germs or bacteria. For example, consider a situation in elevator in a common area. So in elevator, many persons will be traveling, and ye- there there will be a chance of spreading the diseases using this button by pressing it. So similar to that, we can implement this virtual button on top of these buttons and sending it to the elevator, etc. And so that uh, chance of avoiding the affected by the virus can be reduced. Okay, so we are going into the next subsection, IoT. So in this, we are going to see about the MQTT. So the abbreviation of MQTT is Message Queuing Telemetry Transport Protocol. So basically, it's a protocol like HTTP. In HTTP, what we will do is we will send a request and we will get a response. Similar to this, MQTT is a publish and subscribe protocol. So it's a M2M protocol. M2M means machine to machine protocol. What this machine to machine protocol does is so it will communicate between machines without the human to machine interaction. And this protocol is a lightweight protocol, so it can be worked in a very low bandwidth areas and etc. So I'll move to next slide. So how MQTT works? Hmm, there are main three things in MQTT: MQTT broker, MQTT client, and MQTT topic. So basically, what is an MQTT broker is the server which will be running in local or in any cloud. And the operation of this broker is to pass messages from one client to other clients. So the MQTT clients are the devices which are connected to the MQTT broker. So for example, I'm having a local MQTT broker running in my machine. So there are many MQTT brokers such as Paho MQTT, Hive MQ, and Mosquito. So I'm using Mosquito in my local for this session. Yeah. So the next thing is the MQTT topic. So before MQTT topic is a string which is used to the broker to identify the message and send it to the subscriber. So we will see what is the publish and subscriber in the next slide. So So basically MQT transfer messages using publish and subscribe method. So yeah. Mm, okay. Here both the publishers and subscribers can be the MQTT clients. So each client can be both a publisher and subscriber. So in MQTT protocol, sending a message to another client is called publish. The sending a message, that message contains two parts, like one of the thing is topic and the other thing is the message body. Then to receive a message, each subscribe each client need to subscribe to the particular topic. So if the client is subscribed only, so it can get the messages on that topic. So I will just have a small example on this how MQTT works. So we will consider this publisher as a temperature and humidity sensor. So what this temperature and humidity sensor will do is, so it will just send the temperature value and the humidity value to the uh, MQTT broker for each second, for example. So for example, if the topic for this temperature to receive this is a temperature, I will just have it as T, and the topic of this humidity is HU. So, so if this subscriber wants the temperature data, he should be subscribed to this temperature topic. Then this subscriber wants both the temperature and humidity data. He should be subscribing to the both the temperature and humidity. Okay. So now if the publisher started publishing this messages, temperature and humidity values, this subscriber only gets this temperature data. And this subscriber will get both the temperature and humidity data. It's not like each subscriber should subscribe to only one or two topics, so it can be multiple topics or all topics. So I'll just pause for a second. So yeah, the next thing we are going to see, connecting ESP8266 to the Wi-Fi and with the MQTT broker. So those who wonder what ESP8266 is, a microcontroller. It's like a microcontroller like Arduino, and it can connect to the Wi-Fi. So I have a simple connection here with an LED which is connected to D1 and the ground pin. So just to turn on down off the LEDs. So now we will try to connect to the Arduino. So so this is the sample code to connect the ESP8266 to the Wi-Fi and the MQTT broker. So yeah, just we need two libraries, ESP8266 and the PubSub client. So so for connecting ESP8266 with the Wi-Fi, we need the password name, sorry, Wi-Fi name and the password of your network and the MQTT server. So before I said the MQTT server or broker can be both local and cloud. Uh, so for this example, I am having a MQTT broker in my local. So to use locally, what I can use is just give my IP address. For example, uh, this is my IP address 192.168.1.3. So I can use the same IP address to connect with the MQTT server. And and the default port up for MQTT is the MQTT port. So I'll just give a walkthrough through this code. So first we are giving the serial.begin. What this command will do is, so it will ask the microcontroller to open the serial port at this baud rate. So what baud rate means? The rate at which the microcontroller can send and receive the data. So pin mode. So what this pin mode defines is basically what the pin is output or input. And the next thing we will try to connect with the Wi-Fi. So yeah, so in this setup method, we will be trying to connect with the Wi-Fi network using our Wi-Fi name and the password. So yeah, so this while loop is just to restart the ESP after some time when it is not connected to the Wi-Fi network. So after sometimes it will automatically restart it. So then we are after Wi-Fi connected, we are printing it. Wi-Fi connected. So and also we are calling a setting up a callback method. So what's a callback method is like we will pass the function name as a parameter. So for every for some event, so this callback method will be called. So so after that we are printing this IP address of this ESP8266. So I forgot something. So this setup method is a life cycle in Arduino. So it will automatically called when it initializes this sketch. So after the setup Wi-Fi, we are directly trying to connect with the MQTT server using that IP and the port number. So after this setup, it will automatically call the loop lifecycle method. So yeah, if the MQTT is not connected, it will try to reconnect it. So in this reconnect function, it is we will try to connect. So if it is connected, we are going to subscribing to the ESP LED topic. So yeah, before I explain, so first we need to subscribe to the topic. This after subscribe, we are continuing the MQTT connector. So in the callback method, what we are doing is, I said, so this callback method is called whenever the MQTT or this ESP8266 receives a message from the broker. So we are just printing the topic, and if that received message is on, we are making the D1 pin, which is high, else which is low. So I will just show the example. Yeah, so if you see, I'm connecting to my own Wi-Fi, and it says Wi-Fi connector. Next, I am printing the IP of this ESP8266. So first it was saying MQTT not connected. Then after it was saying MQTT connected. So I can send MQTT messages. So, so before I said, I'm using a local MQTT broker called Mqtt. So I can also send messages to this broker using command called Mqtt publish. Next, minus T indicates topic. So if you see, we are also subscribed to the same topic, ESP LED. So yeah. So if I said, for example, so you will be getting a message here. So automatically the LED starts glowing. So you shall not, I can send any messages. You can see this message arrived at this topic here. So we can control the ESP8266 using this MQTT. So just close this. So for now, we have just successfully connected the ESP8266 to the Wi-Fi and the MQTT client. So just close this. So yeah. So as far as now, have completed the two subsystems overview and IoT. Next, we will be seeing the XR part. So so, so the first thing we are going to see is how to creating an image target in Euphoria. So many of you wonder what is Euphoria. Euphoria is like a library. So it is an augmented reality soft development kit for the AR developers. So what is the use of Euphoria? So yeah. So it is easy to add advanced computer vision functionality to an application, and it allows to recognize the image and objects and interact with the real world. So for example, uh, this is the physical button. I explained this before. So how Euphoria helps here is here to mm, detect this image, and it also helps to detect the uh, place a virtual button on top of this physical button, so that we can interact with the real world objects like this LED. So we can interact with the real world LED by pressing any two of the buttons. This LED will work. Just take a pause. Oh. Okay, next we will be seeing and creating image target in Euphoria. Before that, for using Euphoria in Unity, uh, we need a license. So it's just simple way. First, log into this Euphoria and see and we will develop a license, and we will be creating database in target manager and upload the image target. So this image target is this image, the target image which is used to help us to detect us. So we are going to upload this image target. And so in after this we are going to work in Unity. So yeah, I will give a hands-on session on this. Okay. So we need to log into this developer portal. So just give me a minute. So if you see, I'm having multiple projects. First, you can create an Euphoria license using get development key. So you can give your any name, and you can click on confirm, and it will show the license key. So I'm already having the license key and other things. So you can just copy the license key. Then we will go into the target manager. So in this target manager, we need image targets, which I explained here. So this image targets are like the images used to detect. Okay, for example, I'm sorry. Just a minute. So yeah. So I'm already having this target image. You can just go to add target and choose your file and keep us the default with the swan, and you can add your name and add it. So now this target image is added. So if you click on this show features, so it will display some of the stars. So this stars help us to identify how it can be easily augmented. So and here also it shows the rating from 1 to 5. If it is 4 and 5, it is okay, it can be easily augmented. 3, it will be difficult. If it's 1 or 2, it will be very less, it can detect the object and it cannot be augmentable. So after that, you can click on this download database and select as the Unity editor, and you can download. So I already have this had this download thing. So next we'll be started working on Unity. So yeah. So okay. In this Unity, first we'll be creating a new application Unity, which I already created, and we will switch the platform to Android. And in the player settings, we will be checking the box, and then we will be importing the AR camera, and we will be creating the image target. So first we'll be going to build settings. Here you need to select Android and switch platforms. So for example, iOS, you need to click on switch platforms like here this, and click on the player settings. So in this XR settings, you need to check this box out for your augmented reality. The next thing we need to do is import the AR camera. So yeah, so we need a camera to detect these images and use the other options in Euphoria. Before that, you need to click on this Euphoria engine configurations and add the license there. So the next thing we'll be trying to create an image target. So same thing, go to Fourier engine and click on image. So if you see, it automatically created an image target. So to those who wonder how, uh, we have downloaded this Unity package. We need to import that. So we can go to assets, import package and custom. and click on that, and you need to import the Unity package. So yeah, so see I have already imported the name IoT, and you can also switch between many images. So just I will use this image for now. Then so as far as now we have created an Fourier image target. So the next thing we will be doing is creating an virtual button. For that, first we will create a normal Unity 3D button, and adjust the size of the canvas button and import the hand of images. If you had seen here the virtual image, to create this virtual button we need those images. So we started creating the virtual button. So for creating an virtual button, first uh, we'll create a normal 3D Unity button. So it will be here in the button. Yeah. So those who wonder how this canvas came, so canvas is a container for the UI elements in the Unity. For example, if I create any other UI element such as text, it will automatically being placed in the canvas. So I'll just delete this. So we have created a button, but we can't see, mm, because the view of this image and the view of this button is not correctly there. So how it is like, just I will explain using. Okay, so you see this is our image target. So if you see from the top, we can see this image target, but the button is on a different view created. So so how the now the button which is in the so, so this is button which is in a different view. So we will try to adjust the size of the canvas and the position of the buttons. So, yeah, I just to, so so if you see our image target are in a position 0 0 and everything, so we will be also trying to adjust the position of the canvas. So if you see now we can directly adjust the position of the canvas. So what we need to do is we need to switch into screen space to world space. The main thing of switching from screen space to world space is the one thing is we can adjust the positions, and the other thing is the screen space renders on top of the scene, but this world space renders behind or in front of the other objects. So we're using the world space. So I'll just do position 0 0, and the height and width also I will be trying to keep normal to 1. So yeah. So as I explained before, okay. So our this uh, image target, if we see from the top view, it is like this. but the button is in this view like this. Uh, so what we need to do is we need to rotate this x degree to some words to 90 degree. So okay. So now we will try to switch the canvas positions. Oh, okay. It's because we adjusted the width and height of the canvas, but not the button. So we'll also set it to 1.5. To place a virtual button, this is also like not the correct height. So we'll also try to reduce the height as 0.2, 0.1, and also we'll do 0.3. So you can directly use this mouse to move, and also I will adjust the canvas with the height. Uh, for now, we'll so now we have created this button. Then we need to have the image uh, like this. So for that, we can use normal PNG images. After importing this PNG images, you need to click on that image. Default default it will be on default option. After this, you need to have the texture type as sprite 2D and UI. Those who wonder what sprite is, it's basically a 2D object which have some default textures. Similar to this, you can click on. Okay, just you can click on OK, and you can click on sprite 2D and UI. So after this, we need to use this image. For that, just click on this. We can directly drag the off image. So we will consider normally that LED will be off. Just we can drag and drop this. So if you see that our virtual button has an image, so we will try to adjust the item with this home. So yeah, uh, now we have this virtual button, which is placed over on top of this physical button. So the Fourier will automatically augment this positions and everything. We don't need to specify anything. Anything. So, so now we have created a virtual button. So next what? Mhm. So next we need to download this MQTT library. I will share this in the YouTube comment section, and we need to add this to the assets. After that, we need to write a script to control the LED using our virtual button. So I think now we start writing the scripts. So, yeah. So, so so it said first we need to do import this MQTT library. So I have already imported this library. So next we need to add a script to this image target to control this virtual button and be sending MQTT messages. As default, I have already wrote a script, so I'll just add and explain to you guys. So I have created a script name called Mqtt Connect. I will just add, so I'll explain other these things in a little bit. So, mm, so first we have created the instance for on off button, and to switch the sprites on sprite and off sprite when toggling the on off button, we have created this two sprite. So what this serialized field normally do is that uh, which allows the private object to be visible in the inspector window. So for example, if I remove this serialized field of this on off button, uh, so okay, just loading. So now you can't see this on off button initialization here. The other way we can do is making this as a public, but it's not a correct way. So we are using serialized field. So now it automatically loads. So after that, we have creating a boolean value to toggle between on and off, and also we are creating this MQT client instance from that library we are importing. So similar to what we saw in Arduino code, we are creating a broker host name, broker port, username, password. This username password is your Wi-Fi username and password. As default, the MQTT broker will have this port, and we also need the broker host name, which is your cloud or your local IP address, which is connected to your network. So yeah, void start. So it's void start is a lifecycle method in Unity. So it will be automatically initial called when the script started running. So first we will be adding an on-click listener to this on-off button, the virtual button. So we are having the setting a callback function change state. So what it will basically do is if the button is on, then we need to change it to off. We need to change it to sprite and publish the messages off, and to changing to the false. Just this is a toggling operation for on and off. So we are having just an if condition to check these values are not null. Then we are trying to connect to the MQTT. So after this, we are generating an client ID, and we are initializing here. So after creating a client ID, we are trying to client with the client ID, username and password of the Wi-Fi. So we are just catching the error if there is an error. So yeah. So next, this publish method. Now we can in this method just we are having this line client dot publish. So before we see, we are using the same topic ESP LED, and we are passing this message. So if it will be on or it will be off. So this is the script to control the virtual button. So after that, let's do this. For this on and off button, we can directly drag and drop these buttons. So we can directly drag and drop. If you try to drag and drop this button on sprites, it will not do. So next we need the on and off sprite. So we can just drag and drop the output and the output, right? So I think we can do the end of the session. So yeah. So for now we are done with the XR thing. What you can do is go to File, Build Settings. If you are using iOS, you can try switch the platform to iOS and use. If you are using Android, you can use. So we can just give a build and run. So it will just to say. So it will be automatically detecting your Android device. So for example, you can use build and run and it will be automatically deployed in your local machine. So I think we came to the end of our session. So I can't directly demonstrate this project due to some constraints. So I will just play a video of that. So how it works. So you see, this is a virtual button placed on top of the physical button. See, it's actually like toggling. The sprites are like toggling. So yeah, I think we came to the end of the session. So okay, thank you. I think I will try to answer any questions which were in the comment sessions. Stop sharing. So I think there is no questions in the comment section. So thank you everyone for the opportunity.
Thanks, Sri for a wonderful session. Let's move on to the next session, hardware security in Linux using TPM. I welcome Murugesan and Nandita to present the topic.
Thank you, Shashi. Let me quickly share my screen. Is my screen? I hope my screen's visible. Okay. Thank you for coming to the session today on hardware security in Linux using TPM. I am Nandita. I'm a developer at ThoughtWorks.
Hey, myself Murugesan. I'm also an application developer at ThoughtWorks.
So what we have in mind today for the agenda is a brief introduction to TPM, and we'll talk about some of the core TPM concepts. This is so that you can easily understand what's happening when we are showcasing how to use the TPM. So moving on, you might be wondering what this TPM is and what we're talking about when we talk about TPM. The TPM that we are referring to is something called a trusted platform module, and it is a standard for a secure crypto processor that was conceived by the Trusted Computing Group. At the core of the TPM is a dedicated microcontroller that is used to secure hardware, and this microcontroller is attached to the motherboard. So I mentioned that this is a TPM is a hardware module that is a crypto processor, and you can use it for any of these cryptographic use cases, like say generating keys, or if you want to store keys, store the generated keys, you can sign and you can hash using TPM. And on the receiving side, you can verify that the signature is a legitimate signature. You can encrypt and decrypt using TPM, and You can generate random numbers. And this might cause you to wonder, why should you use TPM? Why not use any other software module? One of the major reasons that I think TPM is much more secure is because of something that is inbuiltly available in TPM called the dictionary lockout. Uh, so say somebody tries to engineers a brute force attack. The TPM has a set value called dictionary lockout reset count. So once the incorrect number of attempts reaches this counter, the TPM gets logged out for a set amount of time, and it is sealed for attacks. So this is one of the major reasons why I think the TPM provides better hardware security. And you can think of the TPM as an inbuilt security module. So you might wonder, like, how does this affect you as a developer, and what can you do with TPM? You can treat the TPM like a key store and use it to store artifacts, and the artifacts can in turn be used to, like, say, authenticate your workstation. The artifacts can be anything like keys or passwords or even certificates. You can build applications that store secrets in TPM and access their secrets from the TPM instead of, say, a database or some other store you would normally use. And any process that needs to secure secrets, such as by digital signing, can easily be made more secure when you're using TPM. However, there is a set scope to TPM and what it can do and cannot do. So a TPM can only store secrets. It will not know what is the information exactly that needs to be signed, or uh, what hash to be using. Those are things that the application that uses the TPM must determine on how to sign, or what message needs to be signed, and what algorithm to use to generate the hash. And the TPM cannot also control what software runs on the machine. So say there's a malware running on the machine, the TPM by itself cannot stop the malware from running. However, it can seal the access to the sensitive secure data from the malware, thereby securing the data. Next up, we'll talk about a little bit about the various architectural components that make up the TPM. So while the TPM is a hardware module, like I mentioned earlier, that is not all that a TPM is. It is also a set of standards that has been put together by the Trusted Computing Group. And these standards define specifications on how you should implement, how a TPM should be implemented, and how these various components in the TPM architecture should interact with each other, and how you can access the TPM hardware itself. So first up, one of the architectural components and the higher level architectural component we have is a block of API layers consisting of the feature API, the enhanced system API, and system API. The system API is the bottommost API layer, and the feature API is the API layer at the top. And as you move up this stack, there is increased abstraction available, and becomes your application can access the TPM much more easily because of the abstractions. However, the system API is capable of providing full functionality, uh, full TPM functionalities. Next up is the something called the Tpm Command Transmission interface, and this interface is responsible for handling all the communications from and to between the lower layers in the architecture and the API layers. Uh, and you would need different interfaces for different kinds of TPMs. And what I mean by different kinds of TPMs are, say, you could have a TPM device that is locally present and is a hardware in your machine, or you could be trying to access a remote TPM. And these are like just two examples off the top of my mind about what different TPMs are. And this TCTI layer will take care of the nuances and the differences between the different TPMs involved. Next up, we have something called the TPM Access Broker, also called commonly as the tab, and the Resource Manager. The access broker manages access to TPM from multiple processes that are trying to access it simultaneously. So the tab also guarantees that any process that is using the TPM will be able to complete its operations without being interrupted by any of the other competing processes. The resource manager will take care of switching contexts for the different applications. This is necessary because TPM as such has very limited memory available on it, and it is not possible to like load a lot of things in memory upfront. So every process would need to load its memory and flush its memory when it's done using the TPM. So the resource manager takes care of that for you. And while the resource manager is not a mandatory layer, if you don't have a resource manager, the application must take care of switching context and flushing memory when you're done and loading in memory, things like that. And finally, you have the device driver, and this device driver is a component that is directly communicating with the TPM. This is OS specific, so you would need different drivers for different operating systems. And this handles handshaking with the TPM. This establishes contact with the TPM, as well as all reading and writing to and from the TPM happens via the device driver. So before we go into how it's architecturally arranged, I want to take a moment to talk about certain things that are specific to the Linux ecosystem. So in the Linux ecosystem, you can access the hardware TPM if you have one at either of these paths, either the device's TPM0 or the device's TPM RM0. So what are the differences between these two paths? The TPM0 is the path to the it's the direct path to the TPM device itself, whereas the TPM RM0 provides access to the resource manager and can be used when you have multiple processes that simultaneously want to use the TPM. The TPM0 allows only a single process to access the TPM at any given point of time, and generally or most commonly you would be using TPM RM0 because many applications might want to use the TPM simultaneously. Also, I mentioned the tab or the access broker and the resource manager earlier. So you could either use the Tpm2 ABRMD tool, or you could use an in-kernel resource manager. Uh, Starting with Linux kernel versions 4.1.2, there is an in-kernel resource manager for TPM available. So if you are on the later versions of Linux kernel, you could try using the in-kernel RM. Otherwise, you would need to be using the TPM2 ABRMD. So for the next, here what I have on the left side is the complete TPM2 software stack. On the top, as you can see, is the application, and we have the API layers right below that. We have the TCTI layer, the tab RM, we have the device driver, and finally the TPM device itself. As you can see here, the application can talk directly to any of the API layers. It can talk to the FAPI or the eSAPI or the SAPI layers, but accessing it at different layers mean accessing it at different levels of abstractions, and it might make the access itself and the complexity of accessing the TPM itself might be harder as you move down this line. And on the right, what I have here is is an implementation that is commonly used in Linux. All of these are open source tools: Tpm2 Tools, Tpm2 TSS, and Tpm2 ABRMT are all open source tools available for Linux. Um, so the Tpm2 tools is a command line utility available for you to generate keys or sign messages or generate hashes. It's a command line utility available for you to use the TPM functionalities. Any application you write would sit parallelly to this. The TPM2 TSS provides all of these functionalities that are in blue here, and you would need a tab RMD. You would need a tab RM, and you would need the device drivers for the TPM, and your TPM itself could be any of these possible different things. So next up, we have, I want to talk about some of the core TPM concepts. This is essential. So if you were to actually use the TPM2 for any of the functions, you would need to understand what all of these different terms and jargons mean. So first I want to talk about hierarchies. You can think of a hierarchy as a tree-like structure with the primary key at the top. And it's a collection of entities that are related and managed as a group. Depending on what you want to do with the keys that you generate, you have 4 different types of hierarchies, and any key you generate will be generated under a given hierarchy. And depending on what the key should be used for, it falls under a different hierarchy. So we have 3 persistent hierarchies called the storage or the owner, and we have the endorsement hierarchy and the platform hierarchy. The storage or owner hierarchy is generally used by the user of the machine or the admin/owner of the machine, and it's generally used when you want to, like, say, use the TPM itself as a key store, or if you want to use it for non-privacy centric operations. The endorsement hierarchy, on the other hand, is used by the privacy administrator, and this is used when you have privacy concerns, serious privacy concerns. You would be using the endorsement hierarchy. The platform hierarchy, on the other hand, is used by the device manufacturer, and they would use it to ship in uh, secrets during the manufacturing time that are used later on while booting, or as so on and so forth. And finally, we have one ephemeral hierarchy, or an ephemeral hierarchy means a transient hierarchy, or keys that are generated under the ephemeral hierarchy will not be persisted. And you might wonder, why is that so, or how is that made possible? So for you to generate at the top of every hierarchy, what we have is a primary key, but the primary key itself is actually generated from something called a seed. And this seed value is a constant, remains the same for all the 3 persistent hierarchies. The seed value is a random number generated by the TPM, and this value remains the same for all the 3 persistent hierarchies. Whereas for the ephemeral hierarchy, this seed value is regenerated upon reboots. And while we say these are the keys are persistent, they're not. They might not be actually saved in the TPM's memory. So how that works is, every time, because the seed itself is does not change and is persisted across reboots. Every time you use the same seed and you use the same algorithm to generate a key, you would end up with the same key. So that is how the primary key or any of the keys under the persistent hierarchies are made persistent, because the seed does not change. And because the ephemeral hierarchy has a changing seed value, it is not possible to recreate the same key you used, say, during the last reboot cycle. Uh, that is one of the primary differences between how these hierarchies operate. And as you can see, from the seed, a primary key is created, and from the primary key, children or signing keys are created. I want to make this distinction. I want to call out that the signing keys can only be children keys, because the primary keys cannot encrypt. The primary keys cannot be used for signing. The primary keys are solely there to encrypt the children keys and decrypt when the children keys are loaded into the TPM's memory for signing. Only the children keys can be used for signing. So as you can see, the keys, any of these keys which are not the primary keys, can be used for signing. Whereas this key in yellow here, which is a primary key, cannot be used for signing. And how do we, and you can also see that the blue key here is a parent to these 2 other keys. And how do we specify that a key can be used for signing and a key cannot be used for signing? We have something called key attributes. What I have here is a list of some of the most commonly used key attributes. And when you create a key under a hierarchy, you would there are either some default attributes, or you can set these attributes to specify what the key should be used for. Um, so something else also to mention, it would be, it is also possible for you to change the position of a key in its hierarchy, and that is where uh, the fixed TPM and the fixed parent attributes come in. So if you have a fixed TPM attribute set, this key cannot be duplicated in any way, and it cannot be recreated in another TPM. A fixed parent attribute, if set, means that this key cannot be changed or moved in the hierarchy, and it always has the same parent. And a decrypt attribute means that this key is allowed to create children keys and load children keys in memory, and which also means that if this attribute is set, the key can be a parent key. The sign key, on the other hand, needs to be set. If you want to create a key, say for the purpose of signing, you would need to set the sign key. And the restricted attribute means that this key can only sign hashes that are generated within this TPM. The TPM would have to hash the message, and it would sign only that hash. If you have a hash that was generated outside of the TPM, say yes, using software or in another TPM, you cannot use the key to sign that hash. So tying this back to here, say the primary key would have the decrypt flag set, decrypt attribute set, whereas the keys in green here, as you can see, would have the sign flags set for them to be able to sign, and the blue key here would have both the decrypt and the sign flag set. The decrypt flag allows it to create the children keys, and the sign flag would allow this itself to create signatures. So while you now know that there are keys and you can create signatures, but how do you like really access the keys? Let's say you have a key already in the TPM. How do you access the keys? So to refer to the keys and any object in memory, in the TPM's memory, we have something called handles. A handle is a 32-bit value used to reference an object loaded in the TPM's memory. And a handle can refer to either permanent or persistent or transient entities. And these entities are different depending on where they are stored in the TPM and how they are stored in the TPM. A permanent entity is an entity that is referred by a permanent handle, and this handle and what it points to is defined by the TPM specification. It always points to the same thing and cannot be changed. A persistent entity, on the other hand, refers to a persistent entity on the other hand refers to keys that are stored in the TPM's non-volatile memory. These can be uh, changed uh, because the TPM has limited memory. You would possibly want to change these at different points of time, and you would want to store different keys in the NV non-volatile memory. Transient entities, on the other hand, um, these are handles that are created when you're in the middle of an operation, or just say you load something in memory for the sake of an operation. You would have a transient entity. You would have a transient handle pointing to a transient entity, and it is possible for you to save something that is loaded in memory, that is essentially a transient entity. It is possible for you to make a transient entity into a persistent entity and store that in the TPM's memory uh, using this command called evict control, which we'll talk about later. Uh, that's it about handles and entities. And so while we said the handles are 32-bit values, right? What makes your life a whole lot easier when you're developing using TPM or you're working with TPM is knowing what handles refer to what keys. So a handle, say within this range, always refers to keys created under the storage hierarchy. A handle created within this range always refers to keys created under the endorsement hierarchy. And similarly, handles created within this range always refers to platform keys or keys created under the platform hierarchy. These are not the only handles that are possible. There are like there are lots of other handles, but at the top level and for the demo, I think understanding these handle ranges would have you covered. So it is possible for you to have very different handles, and those handles could refer to other things that are used by the TPM, say something like platform configuration registers, or can be used for the non-volatile memory. But yes, these are the basic or commonly used handles. Next, moving on to the demo, handing over to you, Mqtt.
Okay. So welcome to the demo part. So in the next 20 minutes, we will be going to explore few of the TPM commands. So hope my screen is visible and my font is okay. So we'll be using the Tpm tools command line utility to explore or to interact with the TPMs. So we'll start with the first command, the capability command. So this command is basically used to query the TPMs for various capabilities. Like it can be used to query what are the properties that were fixed inside the TPM, and what were the handles that were transient, and what are the persistent handles, and what are the permanent handles. So those things you can use this command to query. So basically all command takes some common options, like it takes a TCTI name, so which is nothing but TPM command transmission interface. So this is basically used to communicate next down the TS stack. So it takes these three TCTI values, like as we mentioned earlier, tab RMD, which is nothing but TPM new SS broker and resource manager, and you can talk to via socket, and you can talk to via device. So this device will in turn have two files, like one is the default device raw file, like that is dev/tpm0. So basically when we are using this device to talk with the TPM, so we should be explicitly handling the resource management by our own. So we are responsible for the resource management. So since the TPM has a limited memory, you should be swapping out and flushing out the memory then and there. And on another disadvantage is that when we are using this device, so so you cannot access the TPM parallelly, like only one application can access the TPM at a time. So multiple applications cannot be accessed via using for a TPM. So the another file is dev/dev tpm rm0, which is nothing but resource managed version of the above file. So this file will be added to Linux 4.12 and greater versions. So this is the in-kernel resource manager device file that you can use it to talk with the TPM. So here the TPM, the resource management and context flushing, everything will be handled here. So we need not to worry anything. And also if you are using a tab RMD, that will be handled also. Okay. So I'll show you the basic properties that were fixed inside the TPM. So these were the various properties that are all fixed inside the TPM. So you can see this transient, right? So this is 3, which is so what it means is any given time you would be TPM can hold maximum of 3 transient handles. So if you're using, or if you're holding more than 4 transient handles in the TPM memory, then all other commands would returns out of memory or out of space exception errors. So at that point, you would need to restart your system to bring back the TPM to work. So basically, to avoid that, we'll go with the internal resource management or tab RMD kind of thing, so that the resource management will be taken care by the tool itself. We no need to explicitly taken care of the resource management at all. Okay, so moving on. So I am using the TPM tool version 3.1.3. So basically, all Linux distributions, the package managers will have this TPM tools, or else you can also install it by building and compiling the source code. And so as you see, this is the TCTI value that the command is assigned. We are basically using the tab RMD. Okay, so let's move on to another set of commands. So I would like to show you this create primary key command first. So what this command will does is, this command basically create a primary key object under the specified hierarchy, and it will return the transient handle. So what transient handle means, the handle value won't survive across the reboots. So that is the transient one. And as I mentioned, it takes a hierarchy. You could specify either owner or platform or endorsement or an hierarchy. And for each hierarchy, we can also set the password. Like if it has any password, you should be mentioning that password as well when creating a key. So right now, this device has no password set on the hierarchies, but you can set those as well by using the another command called Tpm2 take ownership. So in that way, you can set the passwords for the hierarchies. And this is the key password. If any password that we want to set for the key, we can use this flag. And this is the algorithm for the hashing. So basically, this TPM2 supports a lot more algorithms than TPM 1.2. So earlier we have a TPM 1.2 version. So now the TPM2, it brings more algorithms supports. So this has algorithms. You can use some SAR 256 or SAR 1 or algorithms. And another thing is the key algorithm. So you can specify whether you want to create an RSA key or ECC key. So that it takes a key algorithm as an argument. So this ECC algorithm is supported, or it brought in the TPM2 version only. So earlier it don't have the ECC algorithm support. The only algorithm it supports is RSA. And this is an optional file. So if we want to save the context locally, then we can use this option to specify the file to save the context. So I will tell more on this context when we move on. Okay, and the abject attributes. So this one, as we discussed earlier, so there are a lot of attributes you can set on the keys. So these were like the default attributes for the keys, and you can even specify these attributes set when creating key by passing this -a flag. Okay, so let's move on and creating the key. So I'm creating the key under a owner hierarchy, and I'm using the SAR 256 algorithm, and I'm using the key algorithm as RSA, and I want to save the context in the context.out file. So it would take some time since we are touching the real TPM hardware. So you can think like, so the operation performed on a CPU is much more faster than operation that been performed on the TPM. So by design, TPM it's slow in design. So yeah, so we created a key, and this is our transient handle. So what I will do is I will going to make this transient handle as a persisted inside the TPM. For that, we can use the command evict control. So this is one interesting command. So this command can be used to either persist a transient handle, or it can be used to evict the persistent handle. What it means is it used to delete the persistent handle that is stored inside the TPM as well. So both way we can use this command. So this command takes an authorization value. So since it's an owner, the key has been created under owner hierarchy. I am specifying it as an owner. And first we will try. So every command will take a handle or a context. So you can access the keys via a handle or a context file as well. So first we will try, since we have a handle in place, I'll try to access use this handle itself directly. So this is our transient handle, and this is the handle we want to persist the key. So if you look at this persisted handle, it takes the range start from 8.1. Right. So this is the defined range for the owner hierarchy. So it starts, the most significant octet starts from 8.1 followed by 00, and it would specify the range from 8.00 to 8.FFF. Okay. So handle, okay. So I will tell the what is the handle means. So the handle is nothing but it's a pointer to the resource. Like the resource would be anything. It could be a memory location, or it could be a file, or it could be a network event. So the kernel will give the handle to the user space. So the user space can refer the kernel objects through this handle. So I am using this. Yeah. So I want to make this key persistent within the given handle. Okay. So if you see, we are getting an error. So let's see what that error is. And I will tell you why that error is occurred. Okay, we are seeing that no handle map entry for that particular this handle. So since we are using the TCTI as a tab RMD, the transient handles would have been flushed out when we exit from the command. So that is where the resource management comes into play. So that's why I told we might need to save the context file as well. So now if we have the context file in place, then we can easily access the handles by using the context file also. So now I'm switched to the context file. Yeah. So now if you see this handle being persisted in this given location. So you could see what are the handles that were persisted inside the TPM by using this list persistent command, as well as like earlier I told, you can use the get capability command to query the persistent handles also. So this should also give the same result. So this is the handle that currently persisted in the TPM. Okay, so let's move on. So if we want to access the public portion of the key, we can use this command read public to access the public portion of the key. Okay, so the private portion by itself cannot be taken from the TPM outside. So that is what the whole purpose of TPM. So it kept the private portion securely inside the TPM, so no one could tamper and get it. So only you can get the public portion outside. So now what I do is I will read the public portion alone from this handle. I'll save that public portion to a file called pub.out, and I want to write that in a format, fem format. Okay, let's see the output. Okay, so now let's open the file pub.out. Okay, now you can see the public portion of the key in the fem format. So this is our public portion of the key. Oops. Okay, so moving on, next topic. So next what we can do is we'll create one signing key, and using that key we can we'll be going to sign some data and we'll verify that signature. So for that we need a signing key. So for creating a signing key, we have a command called get pub ak, so which is basically an attestation key which have the sign attribute. So we can use this command to create a signing key. But this command in turns need a endorsement handle. So before even creating attestation key, we would need a endorsement key. So for that, what I do is I'll use this command for creating an endorsement key. So what this command will do is this will create an endorsement key, and it will return the public portion, and it will save the, it will make make that endorsement key persistent in this given handle, and it takes you can specify the algorithm as well. So here, if you see the range, the most significant octet is 81, and the value is here, the 23 to 16 bits values here is 0, 1. So this is the range for the endorsement key. So now we have created an endorsement key. We can see the public portion in a file. And next thing is we need to create an attestation key using this endorsement handle. So this is my endorsement handle, like I have said here, and this is the key handle for this attestation key, and this is the public portion of the attestation key. So yeah, now we have created the attestation key as well. So now we can check the list persistent. So we would see the 3 keys. So if you see, first 2 keys is not with the sign attribute, and this attestation key that we are created finally, right, that one alone has this sign attribute. Also it has the restricted flag. I'll tell you, yeah, so as we discussed earlier, since it has a restricted flag as well, we need to tell the TPM that the hash being created by the TPM itself. So if you are using any other hashes created by outside, this sign won't work, or it won't accept the hashes. So for that, we would need a sign that should be created by a TPM. So we would need a hash that should be created by a TPM. For that, I will use this command. This is the command used to create a hash value for the data. So here, if you see, this is the hierarchy. So since this attestation key is an endorsement hierarchy, I'm using this hierarchy as endorsement, and I'm using a hash algorithm as SAR256, and I am saving this to an hash.bin. And this ticket file is interesting. So this file is the key to know the TPM that this has been created by the TPM itself. So when we use so when we create use the sign command, we need to pass this ticket.fin file as well, so that so this will act as a proof for the command that the has been created by the TPM itself. So we'll try this. Oops, I haven't created a data file. So I'll create a data file saying simply sample data, and I'll write it to data.txt. So now I will hash this data. Okay, so now the hash been created, and you can see the hash bin on the ticket bin. So now let's sign this hash by the sign command. So this sign command basically takes a handle and the algorithm and the data and where I want to save the signature. So and the ticket file. So as I mentioned earlier, this file act as a proof for the command to say that the has been created by the TPM itself. So you can perform the signing. I'll run this command. Okay, so this point we have created a signature. So now, so let's verify the signature by using this verify signature command. Let's see it's been able to verify or not. So this command also basically takes a key handle and the hash value, which is the hash bin, and the signature, which is the sign.bin, and the optional ticket file where we want to save the ticket information of the verify signature command. Okay, let's run this command. yeah, if you see this being verified, if it is verified, it will just print the sign value of the whatever the sign value that we give, that will be printed in the output. Okay, so now let's pass the different data. So I previously we had hashed it for the sample data. Now I am using some other data, wrong data. I want to save this on a file, data1.txt. So now if I run, I want to save this ticket on a different file, and this is my signature. And this command, either you can specify the hash or you can specify the algorithm and the data file. So thereby it itself create a hash as well. So if you have a hash in hand, you can specify the hash directly, or else you can specify the algorithm and data, then that it would create. So now here I am specifying the wrong data, which is different data, but the signature being created for some other data. Let's see how it tells. See, we can see that the signature verification being failed. So this is how we can create a signature and verify it in the TPM. Okay, so now let's moving on to the next portions. So I will show you some of the NV related commands, so which is basically a non-volatile memory in TPM. So these were the NV commands that are available in the TPM. So which is basically used to define a space in an NVRAM, and you can write the data to it and you can read it, and basically you can think of like a storage. So where you can write define some space and you can write data and read it, and you can delete that space as well. So I'm going to give an examples for few of the commands, like how do we define the space in an NVRAM. So for that we can use this NV define. So what it does is it will take a handle. So this is just the pointer to that space in a NVRAM. We can give this indices. So like we mentioned earlier, this NV indices also takes some ranges. So it is from starting from 0, 1. The most significant bits will be 0, 1. And then the auth value, this is the owner auth value. Okay, how can we, yeah, so if you see the permanent handles, that is where permanent. So these were the permanent handles that we mentioned here, right? So this is the permanent handle for the owner, and this is for platform and so on. For endorsement, it has some value. So this is the exact handle value for the owner. So this command takes the auth value and specifying it as an owner. Okay. Oops. Okay, and so this is the size of the space. Like you can give at most 2048 bytes. So now I'm specifying it as 1000 bytes max. And this is the attributes, like what are the specific set of attributes for this key. So I will define this space. I think the space been already there. Let's use a different indices. I'm going to use some random value. See, this space is defined in the NVRAM. Now we can write some data to this space. I am going to write so I'm going to write the data that we have already. So that is this sample data, and I'm going to write it in this space, which is 019, and this is the auth value. So let's write this data. see this data being written to this particular position. So you can see the what are the NV handles that been there in the TPM by using this Tpm2 NV list command. So here, if you see, our handles would be there. Yeah. So if you see this 19 is there. Since this 16 been already there, we are not able to use this. So now this 19 also defined, and it's the attribute value this, and the size is 1000 that we specified. Cool, right? Okay. So next, what we'll do is we'll try to read the data from the location that we return. So this is the location we have written the data, and we can specify how many bytes we want to read. So since the space has 1000 bytes, so the data that we are written, only the 10 bytes. So if we want to read only that portion, we can specify the size. And also we can specify the offset also where we want to start our reading. So it takes all this. If you not specify the offset, it will by default 0, takes from the 0th position. And if it is not size be not specified, by default it will return everything in that location. Okay, now let's see the message out and see the data that we are written. Yeah, this is the data that we are written, and this came. We can even compare it with the data that we are written. Okay, this is sample data. So why this A is missing is because we have read only the 10 bytes from the data. So if we want to read full portion, I can specify 1 more bytes so that it will come as sample data. Okay. And so we could delete the space that we are created also, so that for that we can use this nv release command, which basically releases the space in nvram. So I want to release this space that we have created. Okay, so now if you verify it in the nv list, this should not be there. Okay, and if you see this 16 alone is there, the 19 that we created is gone. Okay, that's all for the TPM commands demo. So also we would like to show you some use cases of the TPM, so where it can be used. So one among them is you can use the TPM for securely boot your device. So I'll going to explain how can we make use of TPM to securely boot our Linux devices. So let's say, so if the security of any operating system layer depends on the security of every layer below it, right? So if the CPU can't be trusted to execute code correctly, there is no way to run secure software in that CPU, right? So if the bootloader has been tampered with, you cannot trust the kernel that the bootloader boots. So here you can say like even I can use the UEFI secure boot and all, right? So even when you're using the secure boot that allows the firmware to validate a bootloader before executing it, but what if the firmware itself has been backdoored? You have no way to verify that, right? So this is where we want a TPM kind of solution to securely boot. So what a TPM does is it has a collection of registers called platform configuration registers, which is nothing but PCRs. So what it does is during the boot process, the system will generate cryptographic hashes of the boot components and pass these hashes to the TPM. So any modification later on to this boot components will changes the hash value, and by consequently it will also change the values recorded by the TPM. So how the hash has been written into the TPM? So when it given to the TPM, so they are not written directly to the PCRs. Instead, what PCR will do is it will try to derive a new combination out of the data. Like if you let's say if the component to be measured is the string hello world, and the PCR's current value is some hash. So what it does is it will append the hello world hash to the previous hash that it has. So it is basically a concatenation of the hash value. So why do like this is so that it ensures the order how the components boot. Let's say if you are booting the components like let's say the first component be hello world and the second one be hello moon. So if you change the order, then it won't allows you to boot. So in that way it ensures the orders also. So the components are measured into a different PCRs. Like basically the TPM has 7 PCR values, starting from PCR 02 and PCR 7. And so at any point in time, if by looking at the PCR values and comparing that with the expected values, we can tell whether any part of the boot process has been tampered or compromised. So this is how the TPM ensures the security of the booting. I will stop here and I will pass on to Nandita for the simulator steps.
Okay.
I will 1 minute. I will stop sharing.
Thank you.
Okay, over to you, Nandita.
Thank you, Jason. So I want to take a moment to talk about simulators. So what happens if you don't have access to a TPM, a device which has TPM, or setting up all these different tools can be a little tricky. So in that case, if you either don't have access, or if you don't have, if you're unable to set up the all the different tools that are necessary, or if you just want a quick way to explore TPM, you could take a look at the simulators that are software simulators that are available. There's one by IBM called the IBM Software Simulator. It's available on SourceForge. This is one simulator that is available for Linux. There is also this library. This one by Stefan Berger. It's called the software TPM. This is open sourced, and this is one of the other simulators you could try. And if you just want like a quick way to check out what a TPM is and explore it and have fun hacking at it without going through the hassle of setting up all these different tools, you could try this Docker container called from Starlab.io. And while this Docker TPM2 emulator image does not have all the functionalities of TPM, say for example, it does not have TPM get capabilities. You could still try out the primary generating primary keys and signing, and those are you could try out the basic operations. With this Docker image, you wouldn't need to install any of the tools, any of the other tools like Tpm2 tools or TSS, or have to install a tab RMD or anything. All of that comes packaged within this image itself. But if you are using either of these simulators, either of these software simulators, you would still need to uh, install the tools for the components higher up in the stack. That's all we had for today. Any questions?
Thanks everyone for joining, and thanks Nandita and Murgesan for a wonderful session. Thank you everyone. Hoping to see you back in the next edition of Geeknight Coimbatore.